Okay, guys, today I'm going to talk about reactions of amides. So I'm going to start with the preparation of them, how to make them. So not really a reaction of an amide, but how to prepare them, how to make them, and then we'll talk about the reactions that they undergo. There's really only two reactions we have to worry about, one making them and one breaking them back down, because these are some of the more complex ones that we see. So we don't go much beyond the complexity of an amide. So how we make an amide is actually, it's the reaction of a carboxylic acid and a primary or secondary amine specifically. A tertiary amine would give us something a little weirder, so we'll not worry about that to start with. So the amidification reaction, as it is called, is we react a carboxylic acid with an amine to produce an amide. So here are three examples of ammonia, which is sort of a zero-order amine up here. So ammonia can react, and then primary or secondary amine to give us an amide. So what is basically happening here is this should look familiar. This should look a lot like an esterification. What this is, the nitrogen with its lone pair, just like oxygen has a lone pair, comes over here and attaches itself to the carbon atom. So it attaches itself to the carbon, and then what happens is this hydroxyl group leaves and takes one of the hydrogens from the ammonia or the amine with it. Now this is why you don't get a reaction with, you get something different with a tertiary amine. Because it's got to take the hydrogen off of the nitrogen and go form the water over here. And what's left is the nitrogen stuck on. So you see the two hydrogens here, 1, 2, are here and here. Down here, it's the same thing. Nitrogen comes over here, this takes this hydrogen and goes away. So we're left with a hydrogen and an R group. Down here, same thing. Takes the hydrogen away, and then we're left with R group, R group, R group, R group. So if we do this reaction, we try to predict these reactants. I'd like you to stop or pause the video and then try these. What you should get from this first one is you get carbon, carbon like this. And then instead of an OH here, so I'm just drawing the same structures of carboxylic acid, but I stop when I go to put the OH, and I stick this nitrogen here, so an N, but the H is going to be gone. The H has gone away. So I've got C and C, so this nitrogen has come here, and then plus H2O, the water has left. That's where the OH and that H went. So this is my final product. The second reaction here, nitrogen comes over here and attaches itself. So we get C, C, C. We get 4 carbons in a row. And then again, where I'm about to draw the OH, I draw nitrogen, C, C, because this has come here. This group is this group, and then plus water. And then finally, this last one, we're just sticking nitrogen on here. So we get C, CO, NH2 plus water. And that was supposed to be a 2. It looks like a 3 because a little tail I put on it. Should be a 2. And there we go. And that's amidification. Once we've made an amide, we can break it back apart. Now this is a lot like ester hydrolysis. Now remember, with esters, we had ester hydrolysis and saponification. There's sort of a historical reason that saponification is separate. We don't have that with amides, so we just call this hydrolysis, but we can do it with either an acid or a base. So it's sort of like we're just taking what would be saponification and calling it hydrolysis also. So there's two possibilities. Now, here is the generic. This is the generic. Now, this never actually happens unless you have like an enzyme, which we'll talk about later. But this is kind of the generic form. What we're doing here, and I want you to just keep this only loosely in your brain. Don't attach to this very, very much, because this isn't what you're actually going to be looking at when you look at reactions. But I want you to see mostly that what happens is this breaks, and the oxygen sticks on here, so we go back to having our amine and our carboxylic acids that we had that would have been put together to make the amide. So this is the reverse of amidification, basically. But there's really two ways this can go down. This can be acidic or basic. Now, in a real sense, you get mostly the same products, but the difference is, notice that what we're producing is we are producing what is an acid and a base, and they're going to be sensitive to acids and bases in the reaction. So notice, if we catalyze the whole thing with an acid, that's going to put a bunch of extra H pluses in the reaction, and they're going to stick to the amine, and we're going to make it an amine salt or an ammonium ion. If we react it with a base, if we catalyze the whole thing with a base, that's going to yank the proton off of the acid and leave it as a salt. So one of the two is going to be turned into a salt, and the other is going to be left alone, depending on whether we catalyze this reaction with an acid or a base. But that's the only real difference in the products between these two. So if we look at this, here's the generic. Notice, again, I break it apart here, and I get my carboxylic acid. But because this was acid catalyzed, we get the substituted ammonium salt. Here, the same amide is broken apart by base to give us the amine and the carboxylate ion. And that's really the difference between these two. The other thing to notice is that for the acid, we actually need to have the water here for the hydrolysis, the acid hydrolysis. But for the base catalyzed, the oxygen and the hydrogen that we need, because an oxygen is going here to become O-, and the hydrogen is going on here, are all in the sodium hydroxide. So I'm going to put together I'll do a couple practices here. So imagine I have this particular Now we're going to do this both ways. We're going to go this way. Well, actually, I'll just draw it again. And we'll draw this. We're going to hydrolyze this by base. We'll have to add heat. And then we're going to hydrolyze this with water and acid and heat. Now I'm going to be a little cramped with my products, but for the first one, I'll draw the first one in blue. My product, well, you can always start, and in fact, when you do a hydrolysis, I suggest you just start by drawing the carboxylic acid and the amine that you'd get. So you always break here, and then I would get NH2, C, and C. And I can now adjust it based on whether it was acidic or basic. So if this is a base, that's going to affect the acid, so we're actually going to draw it as, and then Na+, the sodium coming from here. So there's my two products. The same amide catalyzed by an acid, again, I'm going to start with exactly the same structure. I'm just going to modify it in a different way. So I should have had a plus up here. Plus NH2, C, C. So we broke it here as before, and so, oops, I had copied too much, whoops, I'm sorry. I would draw it as the acid like this, and then the acid being present is going to flood the system with extra hydrogen. So what happens is we get an extra hydrogen protonated here, and the chloride serves as a counterion. So hopefully that is helpful to see. And that summarizes all of our reactions about amides, both making them and breaking them.